Hello everybody, welcome to Maths Unraveled. As you can see, we are solving here today the Australian Mathematics Competition, the Olympiad paper that came in 2023 earlier this year, and we are going to solve the upper primary level. That's for year 5 and 6. Now a point to be noted is in upper primary level you can still use the calculators. For middle primary and upper primary the calculators are still allowed if you need to, but next year onwards, junior division, they do not allow calculators. All right, let's go on. One point to be noted, this is a 60 minutes test. It has 4 sections. I will keep telling you more about each section as we go on. All right, let's start. So this is the first section. There are questions 1 to 10 questions. Each question is 3 marks, and these are comparatively quite easy questions, and it should just take you a few minutes for each question to work out. All right, let's go on. Let's read the first question. This shape is made up of 7 squares. I can see the shape here. Each 1 centimeter by 1 centimeter. Each square is 1 centimeter by 1 centimeter. What is the perimeter? We are trying to find the perimeter. Now let's have a closer look at the shape. And it's given that each little square is 1 centimeter. To find the perimeter, we have to go around outside of the shape. So you can pick, I always tell my students this, pick a point. So you start from here. This is, of course, 1. Then all the way here, these are 3 squares, so 3 centimeters. This way is 3 again. Then up here, this way you will not miss out any edge, even by mistake when you're marking this along. Plus another 1, plus down, this is 2 now. This is 1, and up here, and then we reach the starting point, so this is 2, and now you can just add up these. 3 plus 1 is 4, 6. You can do any which way. I like to put them in pairs so that I don't miss out any. 3, and then is 3 again. So this is 10, and 6 is 16. 16 centimeter is our perimeter. All right, let's see where is 16. Here is our answer, D, 16. That was the answer to question number 1. Let's go to question number 2. There are 5 shapes here, A, B, C, D, E. How many of them are quadrilaterals? Now, quadrilaterals, as you know, is any shape which has 4 sides. Does not matter what are the lengths, if they're equal or not, what is angle between the sides, it should have 4 sides. As we can see in the first shape, this is a triangle, so not a quadrilateral. This is a square, it has 4 sides. Let's check 1, 2, 3, 4. Yes, this is a quadrilateral. This shape, I can see, you can count, there are 5 sides. This is a pentagon. This is not a quadrilateral. This side has 6 sides. This is a hexagon. This is not a quadrilateral. This side again. Now, some of you might get confused, but this has 4 sides. This is actually called a trapezium. This is a quadrilateral, 4 sides. So we have 2 shapes which are quadrilateral. So the answer is 2. Oh, B. This is the correct answer. All right. Now this question, the same question appeared in middle primary as well. Let's read the question. In a board game, Nick rolls 3 standard dice, 1 at a time. So he has 3 dice which he rolls. He needs his 3 rolls to add up to 12. So all the numbers that are shown on the top of the die should add up to 12. His first 2 dice rolls are 5 and 3. What does he need on the 3rd roll to be? Now this, you can see this is 5. The second dice has 3. Now on this one, on the 3rd dice, what number do we need to make it a total of 12? Now, of course, it can be done mentally, but I'll just show you the calculation. 5 plus 3 is 8. 8 plus something makes 12, and that answer is 4. So we need a 4 on the last dice to make a total of 12. So our answer is C. That's the correct answer. Let's go forward. In this diagram, how many of the small squares need to be shaded for the large rectangle to be 1/4 shaded? 1/4 is 1/4. Now this can be done in different ways. I'll show you two different ways. Now we can see there are three groups of 4. So there are 12. There are 12 squares. If we want to divide them into 4 equal parts, that means the answer is 3. That means we need to color in 3 of those squares for 1/4 to be shaded. If you are more of a visual learner, you can look at the rectangle to break any shape or divide any shape into quarters. You need to divide it into 4 equal parts. So I can easily see you can. So if you divide like this, you get 4 equal parts. 1 here, 2, 3, 4. You get 4 equal parts, and each part has 1, 2, 3 squares, 3 squares. So either way you can do, you get the same answer, which is B. B is the correct answer. Let's go on. Question number 5. Petra left for school at 8:51 a.m. She got to school at 9:09 a.m. How long did it take for Petra to get to school? Again, some students can just do it mentally, but if you need a written method, let me show you the steps. So we are looking from the time from 8:51 to 9:09. How much time does it take? And it's still AM to AM, so it's not crossing over. So let's go. Instead of trying to calculate like this, what you can do is try from 8:51 to 9 o'clock. How many minutes to reach from 8:51 to 9 o'clock? That is 9 minutes. And now again, going forward from 9 o'clock to 9:09 a.m. How many minutes is that? And that's easy peasy. That's only 9 minutes. So we can say from here to reach to 9:09 a.m. it is 9 minutes plus 9 minutes. That is 18 minutes. Our 18 minutes is here. This is the answer, C. Let's go forward. Let's read the question. Which letter marks where 25 is on this number line? We are looking for 25. Now we can see there's a 0 here, 40 here, and right in the middle is 20. Now we have 5 options, A, B, C, D, E. We are looking for the number 25. Now of course it can't be A because A is before 20, so 25 can't be that. Now let's have a closer look between 20 and 40. Before trying to find 25, let's see. We know this is 20, we know this is 40. Exactly in the middle, yes, what should be the number here? Think about it. There's a gap of 20 here. So exactly in the middle, we will have the number. Let me write it down. This will be 30. Yes. And now using the same strategy between 20 and 30, this is a gap of 10. So right in the middle, you will find number 25. Now, if you look closely, this does not look like the middle. The middle point is D, which will be 25. So our answer is D. That's 25. This question again appeared in middle primary level as well for 2023. Let's try to work on it. This bottle holds 4 glasses of water. Let me mark it. So one bottle here can hold 4 glasses of water. We can see 1, 2, 3, 4. The question is, which one of these following holds the most water? We're looking for the option with the most capacity. Again, this can be done mentally for some students. If you need a visual representation, a little bit more working out to be 100% sure, you can go ahead. So one bottle here can hold 4 glasses worth of water, another 4, another 4. So together there are 12 glasses capacity in this option. In option B, we can see the direct glasses. So this has capacity of 8 glasses. Here it's 4, 5, 6, 7. So 7 glasses. Now, most of you can see already which is the correct answer, but let me work out to show you exactly. Four glasses can be put in the bottle, and there are 6 more here. So that's 4 plus 6. That means this is 10 glasses. This is 4 here, and 1 here. So this is 9 glasses. So the question was, which one of the following options hold the most water? As we can see, the answer has to be A, 12 glasses. All right. Now, this is an interesting question. Fractions question is actually very straightforward, and I will show you both the ways, a written method, an abstract way, and also a pictorial way. Let's read the question. 2 pizzas are shared equally between 3 students. We have these 2 pizzas here. We have these 2 pizzas here, and they need to be shared equally between 3 students. What fraction of a whole pizza does each student get? Now, this is actually very simple. We have 2 pizzas, and you're sharing between 3 people. Our answer is 2/3 actually right away. You have 2 and you share 2 of something, 2 wholes of something, and you're sharing between 3 people. The answer is 2/3. But if you need a pictorial way, let's have a closer look. Let me remove these arrows. All right, so let's try to divide the first pizza into 3 parts for the 3 students. So it might not be accurate, but I'll try to do. All right, so if we are sharing the first pizza, this is for the first student, second student, and third student. So everybody gets 1/3 from the first pizza. Similarly, because we have another pizza, we are going to divide that into thirds as well, and each of these students will get 1/3 more. So 1/3 and another 1/3 from the second pizza. So each student will get 2/3. And actually you can check 2/3 times 3 students, 2/3. Every student got 2/3. This is actually 2. So yes, so we have 2/3. 2/3 is our answer. Question number 9. This again is a question which is repeated from middle primary level as well. Let's have a look. And this question, as I said, in middle primary, this is a question which requires a lot of visualization. Some students are very good with their visualization. They can look at these mesh and 3D nets. It's sometimes called mesh, some people call it nets. Some people can look at these 3D nets and think about what shape would it make and where would they appear. For some students it's difficult. Even for me, my visualization is not very good, so I employ a method that I'm going to show you. Let's read the question. A piece of card is cut out and labeled as shown in the diagram. We can see here. It is folded along the dotted lines to make a box without the top, so it will finally become a box like this. Sorry, what happened? Where did it all go? Let me find it. Sorry. Okay, we were here. So it will make a box without a top. Which letter is at the bottom of the box? So when this mesh is folded, it will lead to this box, and we have to find which alphabet will be at the bottom. Now, as I said, my visualization is not good, so I try to imagine that if I'm going to fold this box, what is going to happen? I can see that if I folded this line here would get joined with this line here, so that will be folded along. I'm using a different color, and this edge here will be joined with this edge here. Now this will come on the other side, on the adjacent side of D, and the A will actually come this way, and it will have to, let me see, so this edge here will actually join with this edge here. And if I can find one more color, let's say black, and this edge here will have to join with this edge here. Now as you can see, the bottom face is the only face which does not have an open end. All the other faces do have an open end. They all have an open end. So apart from all this, we can see these are open ends for all other faces. Only B is the one which doesn't have an open end, and that must be the bottom at the base. Let me also try to write this. So our D is here. Choose a different color. So we can see C and E are connected to it. C, and if this was face, this is on the right side. E is here. And B is connected to D. So B will go at the bottom. And A, which is connected to B, D, B, A. We can see the order here, D, B, A. D, B, and actually A will go at the back side. It looks messy, but I hope you understand what I mean. B is the alphabet which will go at the bottom. So our answer is B. The last question of this section. Let's read it together. Donuts come in bags of 3, so I can buy donuts. If I want to buy 3, I can buy bags, and boxes of 8. So if I buy 1 box, I'll get 8. If I buy a bag, I'll get 3. I bought exactly 25 donuts for my party. What do I get when I add the number of boxes I bought and the number of bags I bought? Before I can find out an answer, I need to work out how many bags did we buy and how many boxes did we buy to get exactly 25 donuts. And we will see that there will not be many options possible. There will be only one option that can work out to have exactly 25 donuts. Now let me write here, bags and boxes. So in bags, we can only buy in groups of 3, and boxes we can buy groups of 8. All right, sorry, lines are not very straight. So if I buy, I need to buy 25. So let's start. If I buy 1 box, that will be 8 donuts. So 8 donuts, and we still need 25. So that means, we need total of 25. So that means I have to have 17 more donuts, and 17 is not a multiple of 3. So I actually cannot buy just 1 box of 1 box, and 17 donuts cannot be bought just in bags. So 1 is not possible. Okay, you go away. Let's try the other one. If I buy 2 boxes, let's work it out. So 2 boxes will actually give me 16 donuts. To make it 25 donuts, I still need 9 more. And actually, it can work out. I can buy 3 bags, which will give me 9 donuts. 9 plus 16 is 25 donuts, and that works out. And actually, you can go ahead and check more. If I buy 3 boxes, so that will be 24 donuts. 3 times 8. I just need 1 more donut, which I cannot. Even if I buy 1 bag here, I will get 3 donuts, so that will be 27. So that does not work if you had to go and check. So this is our correct answer. Let's see the question which they asked us. What do I get when I add the number of boxes I bought and the number of bags I bought? So you need to add these 2 numbers, 3 and 2. 3 and 2, and that is 5. And this is our answer, B. B is our answer. All right, so this is the end of section 1. We are here on section 2 now. These are questions number 11 to 20. So 10 questions, 4 marks each. And these questions, the questions in section 1 were actually quite easy. Section 2, it goes in increasing order of difficulty. So section 2 is a little bit more difficult, but still much easier compared to section 3 and 4. And these questions, again, should take a few seconds each. 10 questions, let's go ahead. Let's read the question. This line graph shows the temperature each hour during a day. We can see the times are here, and we can see the temperature is along the y-axis. All right, let's read the question. Roughly, for how long was the temperature above 20 degrees Celsius? Now, if we look closely, this is the temperature here. 20 degrees Celsius is here, and we are looking for how many hours was the temperature above 20. So let me on the graph mark it. So above 20, this is the 20, and this part of the curve is all above 20 until it reaches this point. And from this point, it goes below 20 again. So we are only interested in this part of the curve. So let's see what time was it when it started. going above 20. We can see 9 a.m. here, 12 p.m. here. So this has to be 10 a.m. And let's see, it goes on, and it starts coming below 20 degrees after this point. So let's see what's the time here. This is not exact, but this is around 9 p.m. So we can see how many hours has it been. If it was 10 p.m. it would have been 10 a.m. to 10 p.m. it will be 12 hours, but because it's 9 p.m. it's 11 hours. So answer is 11 hours. That's the correct answer. Let's go on to the next one. Oh, again, a very interesting question. If you have a mirror lying around, you can try this for yourself. Have a post-it, a paper, write it on, put it in the mirror, and you will be able to see. This way you can visualize and actually see the problems in reality. Now let's read the question. Viv takes her 3 children, Hannah, Otto, and Izzy, out shopping. So these are the 4 t-shirts they're wearing with their names on. Each is wearing a t-shirt with their name on the front in capital letters. When they stand in the front of the shop mirror, which names appear the same in the reflection? So remember, we are looking for names which will be exactly the same. So let's look for that. Again, just like I said, you can try it in the mirror. If Viv stood in front of the mirror, these letters will be exactly the same. Viv. Hannah, you might think it all looks same, but let's try. H will be the same, A will be the same, N would actually go this way. Oh, sorry, not this way. This is the real way. N would be reflected like this, A and H. So actually Hannah, it does look like Hannah will appear the same, but the N's have changed their orientation, so Hannah is not the same. Let's look for Otto. O, T will be the same, is the same from both sides, so this works, they look the same. Izzy, let's try. I will be I. Z again will change size. It will become like this. You can try it in the mirror, and Izzy will actually appear like this. So Izzy changed direction. So we have 2 shirts which look exactly the same as before, which is Viv and Otto. So answer is A. Let's read the next question. This regular hexagon, the blue here, has angles of 120. So each angle here is 120, and because this is a regular hexagon, each one of these angles are all the same. All 6 angles are 120 degrees. Let me mark the angle just on which we are interested. This is 120 degrees. And the square, of course, they have written for us. The squares has the angle of 90 degrees, but we knew it already. What is the angle X in the diagram? Let's have a closer look now. So they have already given us this angle is 120. This angle, we already know this is a square. This has to be 90. Now we also know that any angle around a point, a complete angle around a point is 360 degrees. Now we can say that if we start from here, it goes around and finishes here. Let me mark the starting point. So if we start from here and finishes over here, go around the shape, it should be 360 degrees. So let's work it out. 120 plus 90 plus another angle X should be equals to 360 degrees. This is 210 plus the angle X that we are looking for is 360. So we can take away 210 from here, take away 210 from here, and we'll find the angle that we are looking for, and this will cancel off. And 360 minus 210 is 150. Our X is 150. This is our answer, D. All right, let's go on. sorry if I pronounce this name wrong. Syed's mother has some money to share with her family. She gives 1/4 of her money to Syed, then she gives 1/3 to Ahmed, and one half of what was left to Ryan. She was left with $15 at the end, which she keeps for herself. How much money did Syed's mother have to start with? Now, in these questions, pictorial way is the best way. It can also be done in variable way using algebra, but many of you might not know the concepts of algebra till this level, upper primary. So I'll not be using algebra for this. I'll be using a pictorial method. So if this rectangle represents all the money that Sai's mother had at the beginning, we do not know how much money is it. We have to find out, but we know at the beginning she gives 1/4 to Said. Let's make it quarters, 4 equal parts, and she gives one of these parts to Said, and now she has this part left over. Now let's see what she does next. She gives 1/3 of what was left to Ahmed. Now we can see from what's left over, it's actually divided into 3 parts already. So we can see one of these boxes is 1/3 of what is left over, and she gives it to Ahmed. Let's see what she does next. She gives 1/2 of it to Ryan. Let's see what is left over. She has this much left over. Not till here, only till this box. She has this much left over, and half of this she gives to Ryan. And it's actually very simple. It's already divided into 2 equal parts. So she can give this to Ryan. And as it says, she has $15 left, which she keeps for herself. And the question is, how much money does she have to start with? Now, because we did not have to partition it any further, since we started from the beginning, all these parts are equal. So if this is 15, this is 15, this is 15, everybody got $15 each, including the mother. So at the beginning we had 15 times 4, which is 60. So she started with $60. The answer is C. Now this question again is a visualization question. Let's read it. The rectangle shown has a side length of 9 centimeter. So we know the longer side is 9 centimeter. We are not sure about the shorter side. It is divided into 3 identical rectangles. All these, if you look closely, this bigger rectangle is divided into 3 rectangles, and they're identical. They're all the same with the same measurements. What is the area in square centimeters of the original rectangle? So they are asking the area of the bigger rectangle. Now to work that out, we need to find out what these measurements are. So we can see that this length was 9 centimeter. Now it's broken up into one piece here, all right, and a piece, so it's broken into one part and another part, which actually will come from this and this. Can you see this is the same as this, the same as this, and also because all 3 rectangles are identical, that means this should be the same as this, which is coming from these 2 parts here. So whatever we write here, there should be double over here to make sure that all these rectangles are identical. So what can we do? So how can we split 9 into 2 parts so that this part is double of what is here? Of course, this is not very tricky. I can split it. This is the first thing that actually comes to mind. I can have 3 here. 3 plus 6 is 9, and this is 6 is double of 3. So this is 3, this is 6, and here 3 and 3 of course makes 6, which makes everything clear. This is, I'm just showing to make sure you understand how did we get it, and it all works. And now we can see what was the area of the original rectangle. So we can see the original rectangle, the length was 9 and the width was 6, so it is 54 centimeters square. Let's see where's the answer, and here it is D. Our answer is D. Oh, I'm sorry, I got confused. I was thinking of this question when I said you need a lot of visualization as well. All right, question number 16. This diagram shows a rectangle with a perimeter of 30 centimeter. The bigger rectangle here has a perimeter of 30. It has been divided by 2 lines into 4 small rectangles. So they use 2 lines to split it into 4 rectangles. 3 of the small rectangles have the perimeter shown. What is the perimeter of the 4 small rectangle? Now again, just like I said, it requires a lot of visualization, but I will try to also show you. So when we say perimeter is 12 for this little rectangle, that means we are calculating this plus this plus this plus this. Now let this be here, and look at this, let this and this be here. Can you see this side is actually the same as this side? So I'm going to erase this and put that here, because finally I know the perimeter of the larger rectangle, so I'm trying to translate all those things up there. Now again, if you look at this side here, this is the same as this here, so I'm going to erase this, which should still be 12. So did you see our perimeter of 12 is actually made up of this side, and this side, which we have translated onto the perimeter of the bigger rectangle, and this. So we got a 12. Let's do the next one. I'll use a different color. So perimeter of 16 is made up of this plus this plus this and this. Now because these two are on the edge already, look at the pink lines, so we are not going to change that, but this side here is the same as this, so I'm going to erase that from here. All right, and similarly, if I look at this edge, this is the same as this edge here. All right, you might notice that this little part here has already got 2 times of it, which will be helpful for us now. So this is 16. Now let's have a look at the next one. So this is made up of this plus this plus this plus this, so this 14. Again, I'm not going to touch this side and this edge, not this side, this edge. Think about this edge is the same as this, so I'm going to translate it, move it here and remove it from here. Similarly, this side here is the same as this here, so I can write it here. So if, can you see all the marks, edges? This is 14, and I do not know what is the perimeter of this 4th rectangle, but I do know if I add this, the final one, let's the outside is 30, but let me actually work this out too. Let me choose a different color. So if I have to find the perimeter of this, it will be this plus this plus this plus this. Again, I'm not going to touch this side and this side, but we can see this side can be translated here, and I can remove this from here, and this side is actually the same as this, so I can remove this here. So if you are able to see why did I do all this, is to get to this point. So do you see, on, look at the outside bigger rectangle, each of the edge, let me not mark it, each of the edge, the whole perimeter is covered twice. Each of these 1 2 1 2 1 2 1 2 1 2, so each edge is covered twice. So that means we are going over the perimeter of the larger rectangle twice. So if I add the perimeter of all the small rectangles, it will be equal to twice the perimeter of the bigger rectangles. We know the perimeter of the bigger rectangle is 30 times 2 is 60, so this must be equals to 60. I hope you understand. Have a closer look at the diagram that I've just drawn. I hope you understand. If there are any questions, drop me a comment in the messages and I'll try to explain it more. And now we can just solve it. 16 plus 40 is 30. 30 plus 12, 42. 42, and perimeter makes 60. So this perimeter has to be 60, take away 42, which is 18. So this perimeter must be 18 in order of for all the calculations to work. So our answer is 18. Let's go on to the next question. There are 10 questions in a test. Each correct answer scores 5 points. Each wrong answer loses 10 points, -3 marking. And if a question is left blank, it scores 0 points. All right. Okay, I did not finish reading. Tycho, is that the name? Tycho did this test and scored 27 points. How many questions did Tycho leave blank? Now we need to work out, there are 10 questions. How many questions did he got right? How many questions did he attempt wrong? And how many questions did he leave empty in order to get a score of 27? So these are the questions which are right, questions which are wrong, and questions which are left blank. So these will get +5, the questions which are correct. Any wrong question will get -3, and any question that is left blank will get a 0. And we need a total of 27 points. All right, let's work that out. Now, using this, we can already say, because we need a total of 27, 5 times, we need anything below 4. If I have correct 4, that will be 20. That cannot give us 27 marks. Similarly, if I have 5 times 5 is 25. That cannot lead me to a score of 25. So my only possible number for correct answers have to be more than 5 in order for this to work. We'll have to try different methods, but let's see. So if this was 6 times 5 is 30, so he can score 30 points here. But remember, our final score is 27. That means he has to lose 3 marks to be able to get 27 score. If he has to lose 3 marks, that means one question must be wrong. So that means it will get -3. And because we have 10 questions in total, and he has already, these are 6 questions here, 7 questions here, that means he must have left 3 questions blank to get 0 marks, and this will actually add to 27. Our first try actually yielded into a result. So this is our correct answer, and it leads to, he attempted 6 correct questions, one question he got wrong, and he left 3 questions unattempted. Now, it's just by chance, but let's see if another answer could work too. If he attempted 7 questions correctly, that means he can get 35 marks from here, but we need 27. That means he has to lose 15, right? 8 marks. He has to lose 8 marks in order to get 27 marks. Now, because each wrong question takes away 3 marks, there is no possibility of losing 8 marks by attempting some wrong question. So I cannot have 8 here in any way. Not 8 questions. I mean 8 marks here. There is no chance that I can deduct 8 marks here, because 8 is not a multiple of 3. So this is actually not possible. And similarly, if we say that he attempted 8 questions, 8 times 5 is 40, he got 40. That means he has to lose 13 marks in order to get 27. Again, 13 is not a multiple of 3, so I cannot have any number here which can lead me to -13. So this cannot work. So actually the first strategy that we applied is correct. They're asking how many questions did he leave blank? He left 3 questions blank. This is our answer. All right, next question. Again, this time they have a lot of questions which require a lot of visualization. I will teach you a way that I use, because I'm not good with visualization. So I'm going to teach you the method that I work with my students on, and the very method that I use. If you have a paper and scissors, of course, fold it and try to do it by yourself. But if you're in the exam and you don't have access to scissors and paper, you will have to use some technique to figure out the answer. Estelle is making decorations shaped like the 8-pointed stars. So you can see the 8-pointed stars here. She's trying to make this 8-pointed star by cutting a square piece of paper. She folds a square piece of paper to make a triangle with 8 layers as shown. So we can see that she starts from here. She folds it along this line to get this, and then she folds along this line to get this shape, and then again using symmetry she folds along this line to get this triangle. And this is the part where she makes the cuts to finally get this as the output. Now which of these cuts in the triangle will lead to the 8-pointed star? Now I will show you the method that I use. Okay, this is the final output that we want, this 8-pointed star. Let's start from the beginning. Imagine it was not cut, so the paper was a hole, and we folded it along this line. Then the second part, we folded it along this line. So this is step number 2. And then look at this part so that we are in the same position as this here. And now it's folded again along a line of symmetry to get a triangle. Let me just, so this was the piece of paper. Let me not draw all of it, just focus on this part. So this was the final square that we folded and got along, and then it was folded again for a line of symmetry to make the cuts. Now we can already see that if we focus on this triangle, these are the cuts she must have made, which will open up to give us the 8-pointed stars. We can see easily. And this cut, let's see, A, B, C, D, E, I can see this is option B. It looks exactly similar to option B. If you want, you can take a square piece of paper and try it for yourself. B will be the answer. This is a very interesting question. Earlier this year, Ben said, next year I will turn 13, but 2 days ago I was 10. That's a jump of 3 years. How is that possible? So now let's take it logically and try to find out the answer, because this is a question. There must be an answer. So how is he jumping in 1 year to 3 years? 2 days ago he was just 10, and next year he will turn 13. Now it might seem impossible, but if you think carefully about it, you can figure it out that actually 2 days ago when he's saying he was 10, that means his birthday was just yesterday, and he must have jumped to 11 years yesterday, and that's why he can make that statement. It still doesn't guarantee for if he's 11 today, how is he going to be 13 next year? Because even if his birthday was yesterday, that should have made him 11, and next year should have been 12 years. So how is he jumping to 13 years in the next year? Now this is the tricky bit. So they're saying earlier this year. So what about if the birthday was at a date that the year itself has changed, and that is what is leading for him to saying next year it will be 13 years. That means this is the current year, and his birthday passed in the last year. He still has to get his birthday this year and the next year. I know it sounds really confusing. So as we said, his birthday must have been yesterday. So that's why he's saying 2 days ago I was just 10 years old. But he's saying next year I will be 13 years old. So you can try different things. His birthday, of course, must have been in December. And this is the statement he's saying must be in the next year. He must be talking in the new year in January for this to be all true. Okay, so we can see we have 3 options. But again, just like he said 2 days ago, I was just 10 years old. And he's already in January saying this sentence, his statement. So that means if his birthday was 29th, he cannot actually say 2 days ago in January, even on 1st January. Similar for 30th, if he's even saying on the 1st January, he cannot say 2 days ago I was 10 years old. So the answer must be 31st December. His birthday must be 31st December. So if we can say till 30th December last year, he was just 10 years old. He's saying all this now in the next year. So that means 30th December of this year, he will be, oh, sorry. I'm sorry, I missed one part. So 30th December, he was still 10 years. 31st December, his birthday, he turned 11 years. And now this is next year already when he's saying that. So 31st December of this current year, he will turn 12 years. And as he said, next year, I will turn 13. So the 31st December of next year. This is next, current, and last year. And he will turn 13 years. So this tricky question is this way. Okay, so the answer that we got is 31st December. His birthday must be on 31st December. So I've drawn this table and we can work out how many stickers does each child have following all the conditions. So let's have Peyton stickers here. How many does Peyton have? Luca and Dan. Now according to the question, Peyton has half as many as Luca. So whatever does Luca has, Peyton has half of it. Dan has 3 times as many as Luca. So whatever Luca has, Dan has 3 times of Luca. So we know all this and the total must be 180. This must be all add up to 180 stickers. Now let's try different options possible. All right, now let's start with the basic number that maybe because we need a total of 50. Let's start with 50. We need a total of 180. Let's start with, if Luca has 50, that means Peyton must have 25. That's half of it. And Dan must have 3 times of Luca. That's 150. And as we can already see, this is 225, which is much, much higher. So we have to go drastically low. Not drastically, a little bit. Let's try 40. If Luca has 40, that means Peyton must have half of that. That's 20. And Dan has triple of Luca. 40 times 3 is 120. Let's see. 120 plus 40 is 160 plus 20 is actually 180. They all add up to 180. And we found our correct answer. But if you did not think of 40, if you were trying different answers, let's try to work it out. If you were thinking of 30, none of the other answers would work, but let me just try out one more. If Luca had 30, that means Peyton would have 15 and Dan would have 3 times of Luca. That will be 90. 90, 120, 135. This is 135. So as you can see, this did not work. You can try different options, but we were lucky we got our correct answer quite quickly. Let's see, what was the question? How many stickers does Peyton have? We can see Peyton has 20. Base answer. Answer is A. Right, we are on the section 3 of our question paper now. This section has 5 questions, 21 to 25, and they're all 5 marks each. And do expect a higher level of difficulty for these questions because these are 5 marks each. Do expect a longer working out, graphical representation, a lot of thinking and working out to finally be able to get the answer. And do make sure you check it over again before moving on to the next question. All right, let's move to question number 21. And for this, I'm trying something new. All right, let's try a black background because I thought it might look cooler and make the question stand out more. All right, let's read the question. Mr. Graff invents a game for her students to practice arithmetic. They roll 2 10-sided dice. I can see there are 2 dice here, and instead of a regular dice which has 6 sides, these dice have 10 sides each. To pick 2 numbers, starting at one of the numbers, they keep adding the other number until they reach a 3-digit number. So they keep playing the game until they reach a 3-digit number, and that is when they stop the game. So for an example, if Ian rolls a 5 and an 8, let's write it down. So he rolls a 5 and an 8. If he chooses to start with a 5 and keep adding 8 and again and again. So he's starting with 5 and he keeps on adding 8 every time. So he gets 13, add another 8, that is 21, and he keeps on doing that, and he will get 93, which is mentioned here. And then of course he add another 8 and you reach 101. And because we reach a 3-digit number, we stop here. All right, he can also choose to start with the 8 and add 5 every time. They have given the series here. So that will be 13, add another 5, which is 18, and keep going on. And the second last number given is 98, and then you'll add 5 and you get 103. Now before moving on, let's try to look at these sequences a little bit more in detail to understand that. Now, because you're adding 8 every time in the first sequence, this is effectively, let me bring it down, this is effectively counting in 8s. If I count in 8, 0, 8, because you're adding 8 every time, 16, 24, and then so on. And the last one would be 96. Yes. And because normal, our counting starts from 0, but because we started from a 5, so we deferred our series by 5. That means to this series you add 5, which we have here, to each term, and you can see the 0 changes to 5, 8 becomes 13, 16 becomes 21, 96 changes to 101. And this can help with our actual understanding and working out the series. Similarly, let's look at this series. Because we are counting in 5s every time, I can just go on. This is easier. 15, 20, keep going on, and 95, 100. And because our series is deferred by 8, because it started with the 8, so that means you have to add 8 to each one of the terms to get the series at hand. So 0 becomes 8, 5 plus 8 is 13, 10 plus 8 is 18, and towards the end, 95 plus 8 becomes 103. So we did not actually have to use 100. The game stopped when it reached 103. Now, let's read the question. The question is, on Nara's turn, she makes a list that ends in 107. That is the only clue given to us, that the list will end on 107. Which pair of numbers she could have rolled? Now, let's work this out. So let's try to work 4 and 8. If she had 4 and 8, let's try to work it here. If she had 4 and 8, let's assume that she starts to start with 4 and count in 8. So again, using our previous method, we can just count in 8s, 8, 16, 24, go on, and using our 8s timetable, we know that it will go to 96, and the number one before will be actually 88. I should write that too. And the other one will be 104. And because the series started with a 4, that means we have to add 4 to each term to get our series for this game. So this will be 12, 20, 28. I don't have to actually work out all of this. I just need to work out when it stops having a 3-digit number. So 96 plus 4 will be 100, and the game will stop here. So it will not be able to reach 107. Now let's take the opposite way. If the game starts with 8 and counts in 4. So let's count in 4s, 4, 8. I don't have to write all that. I need to just worry about the end digits. So 94, 96, 96 is a multiple of 4, 100, and so on. And let me actually write 92 as well in case we need it. All right, because a series starts with 8, so that means the whole series is deferred by 8, so we need to add 8 to every term. So I'm not focused about the beginning terms. I'll be more focused here. So again, the moment I see 92, 92 plus 8 will be 100, and that is where the series would stop. We will not need to use 96 and 100. So our series will stop at 100 again. So this combination does not work. There is no way we will get 107 if the numbers rolled are 4 and 8. So 4 and 8 does not work. And actually, if you apply a different logic, multiple of 4s are always even numbers, and when you add a 8, that will again be an even number. So actually 107 could not have given the answer. If we start at 8 and count in 4s with the same logic, multiples of even numbers are always even, so we could not have actually gotten 107 in any case. Let's start with 5 and 7. Let me choose a different color this time. If we got a 5 and a 7, if we start with 5 and count in 7, so when count in 7s, again we are not worrying about the beginning numbers, we are counting towards the end, where would the series stop. So we know 77 and then 84, and then 7 more is 91, 98, and of course 105. But my series started with 5, so it's deferred by 5, so I'm not bothered by all these. I'm thinking about where will I get the 3-digit number. So 91 plus 5 will be 96, 98 plus 5 will be 103. So I will have to stop at 103, will not use 105, and the the 3-digit number that I stop at is 103, so this does not work. Let's try counting in 5s. So 5, 10, again I'm more focused on the last digits, so it will be 90, 95, 100, and because I had to defer by 7, the starting number is 7, that means we'll have to add 7 to every number. Now I'm not worried here, so 90 will become 97, 95 will become 102. Although some children might get confused that 100 actually turns to 107 in this series, but if you look at the rules really carefully, we will not be actually reaching this level, because the game stops the moment you reach a 3-digit number, so it stops at 102, so it will not be able to go to 107. Let's see the other way. Oh, we have done both the ways, so this actually does not work as well. All right, similarly, let's try 3 and 4. But this requires a lot of working out. 3 and 4, quickly counting in 4s, focusing on the end bit. So 92, 96, 100. If I'm adding 3, so it's 95, 99, and 102. So I got 102, it does not work. But if I count in 3s, let's count in 3s, I know it's 96, 99. Sorry, why did I write 96 2 times? And 102, and because the series were deferred by 4, so I'm adding 4. So it will be 100. Actually, I don't need all this, it will stop at 100. So it did not work. So 3 and 4 also does not work. Let's try 6 and 9. Counting in 6s, so the end numbers would be 90, 96, 90, 96, and 102. Yes, and after adding, because we are deferred by 9, after adding 9, this will become 99, and this will become, adding 9, it will become 103, and our game stops here. 103 is the final one, which was not 107. Let's try counting in 9s. 90, 99, 108, and now adding 6 to each of these. 96, 105. The game stops at 105. This did not work as well. Now the only option left is 3 and 8, and let's try this. It should work, but let's prove that it works. 3 and 8. Let's see if it was the right. Yes, 3 and 8. Let's check which way does it work. Let's count in 3s first. So 3s is 90, 93, 96, 99, 102. If I add 8s, I already get 101 right here. I don't need all this. I already got 101, and which is not the one we are looking for. Let's start counting in eights. Let's start counting in eights. So it is 80, 88, 96, and 104, and adding 3 every time. So I don't have to do all this. I can do here 99 and 107. Finally, we got the 107 that we were looking for. We had to really work out everything to work this out. Now there is a method of finding remainders, adding, but I feel at upper primary maybe this can be better. The work, one of the methods that I worked with one of the students was, if I had to work this out, we could also have done 107 if I was counting in eights. Divide by 8, so that's 8 times 1, remainder 4, remainder 2, 8 times 3 is 24, remainder 3. So do you see, if I use a series counting in eights and there's a remainder 3, and that is what we started with, so it would actually work. But anyways, the written method, I've shown you both the methods. You can choose any method that you like. Let's do the next question. At a school concert, the tickets cost 20 per adult and 2 per child. The total paid by 100 people who attended was 920. How many were children? Now, they have already told us that there are 2 kinds of tickets. Let's work it out. So this is for child, this is for adult. Adult price is $20. And child price is $2 per ticket. We need to buy 100 tickets, and the price paid is 920. Now, just to get a starting point, let's imagine if all the 100 tickets were children ticket. If I buy all 100 children tickets, that will only amount to $200, which is much less than this. Let's see the other end also. If I buy all 100 adult tickets, that will be $2,000, which is again on the other extreme. And can you see the answer, our value 920 is somewhere in between these two amounts. So that means I actually get a reference point, or where should I starting with? I should be starting with somewhere in the center. So let's see, if I buy 50 children, if they bought 50 children and 50 adults. So 50 children will be $100 and 50 adults would be $1,000, and together that is $1,100, which is still above. That means now I need to reduce the amount of adult tickets, because adult tickets are costing more. So let's check 40. If I buy 40 of these and 60 of these, because we buy 100 tickets, 60 children tickets will cost me 120, and 40 children will cost $800, and together they are $920, which was the price. So we worked out which one works for us. The question is, how many children were there? So you can see we bought tickets for 60 children. So the answer is here. All right, so this is the answer for question number 22. Now, this was a question that I had to reread 3-4 times to understand what they mean. Let's read it together. Mina has a standard dice with each pair of opposite sides adding to a 7. So if I have a 2 here, I know for sure on the other side will be a 5. If I have a 1 here, I know the opposite side would be a 6 to add up to a 7. And there's a 3 here, so the bottom face should have a 4 to add up to a 7. All right. She holds the dice between a pair of opposite faces, so she might be holding 1 and 6, or she can choose to hold 2 and the opposite side is 5, or 3 and the opposite side 4. So there are 3 options to hold the dice in this way, that you hold the dice by 2 opposite faces. So she holds the dice between a pair of opposite faces and rotates it 180 degrees. So she's flipping the dice, but there's a condition. She keeps these opposite faces facing the same direction. That means she's holding the two faces. Those two faces do not move, but the other all faces rotate. All right, let's explain. Let's read the question first. She puts the dice back down and adds up the three faces she can see now. So of course we will still be able to see three faces, but the numbers would have changed. What is the smallest possible number, smallest possible total that she would get? Now, just like we said, there are three possible ways of holding the dice. So let's work out the different scenarios. So if she holds 1 and the opposite side 6. So if she holds 1 and 6 between her finger and thumb and flips the dice, that means 2 will flip over to the other side, and we will be able to see 5. Similarly, 3 would go down and the opposite side 4 would show up, and of course 1 and 6 will remain in the same place. 1 and 6 will remain in the same place, so I will still be able to see the 1, the 5 in the new place, and 4. So the total would be 5 plus 9, 10. So in this case, the total is 10. Let's try to use a different scenario. If I use 2 and 5, if she holds 2 and 5 between her finger and her thumb and flips the whole dice 180 degrees, that means 2 will still be seen, but instead of 1, we will be able to see 6 that was on the opposite side, and 3 would go at the bottom, and the 4 would be revealed. So that means now the total total of the numbers that we can see is 2 we can see, and now 6 and 4 are visible. So 6 plus 4 plus 2 is 12, which is of course a higher number than 10, but let's see the other final scenario as well. So 1 and 6 are done, 2 and 5 are done, and the last option is 3 and 4. If she holds 3 and 4 and 3 is still visible because that doesn't change the sides, the other two sides flips because she's moving 180 degrees, rotating it 180 degrees. So the 2 will flip over and we will be able to see the 5 on the other side, and the 1 will go at the back and we will be able to see the 6. So looking at 3 is still visible, and we have 5 and 6 which are visible. So 6 plus 5 plus 3 is 14. So we have 3 scenarios, 1, 2, and 3 scenarios, and these are the possible numbers because we are looking for the smallest possible total, which is this one. So we have the smallest possible total is 10. This is our answer, C. Question number 24. I have 4 whole numbers that add up to 98. Let's keep highlighting the important bit. So 4 numbers that add up to 98. If I were to add 6 to the first number, subtract 6 from the second number, multiply the third number by 6, and divide the fourth number by 6, the 4 answers would all be the same. What is the sum of the largest 2 of my original numbers? Now this is a lot of calculations and a lot of thinking and manipulating and visualizing. So because we have 4 numbers, let's think about the 4 numbers. I'll make space for the 4 numbers. So let's see, A, B, C, and D. These are our 4 numbers, and the total we know has to be 98. Now the conditions are, one of these numbers, I don't know which number, one of these numbers we will be adding 6. From one of the numbers we'll be taking away 6. From one of the numbers we will be multiplying with 6, and the last number we'll be dividing by 6, and the answer to all these calculations will be the same. We will get the same answer from all these calculations. Now let's think about it. Now if we just think about getting a total of 98, there are so many different possibilities that we can spend the entire day here. So let's think about it rationally. To add 6 to a number, we don't need anything much, so there is no restriction on A. To deduct 6 from a number, because these are all whole numbers and we want the answer to be the same from other sides as well. So if I even have 6 here, 6 minus 6 will be 0, which will not be possible to get 0 from others. So that means 6 is not a possibility here. The minimum number should be 7. The smallest number has to be 7. So let me just write it down somewhere. Smallest number is, can be, not is, can be 7. All right, or must be 7, minimum 7. Now again, looking at this C, we can multiply any number by 6, but to divide a number by 6 and get a whole number as an answer, because remember, finally all the answers will be the same. Now this is the condition that we should start with, because all numbers cannot be divided by 6. And if we are saying we are going to divide one of those numbers by 6, that means at least one of those 4 numbers have to be a multiple of 6. Now that is a point where we can start from. So let's note down all the multiples of 6. Now, all right, I could have gone further, but as we realize, even if I choose 96 to be here, that means I only have 2 more, which I have, but I have 3 more numbers. So 96 actually would not work. And even if we have 90, if we try to put 90 here to make a total of 98, we just have 8 more. And we have just said that 7 has to be the smallest number. There cannot be a number smaller than 7 possible. So again, we will not be able to have 3 more numbers. So 90 will not work as well. Let's try to work with 84. If I have 84 here, and if I divide 84 by 6, my answer would be 14. The issue is, of course, I can get 14 from here and here, but there is no number here that I can multiply by 6 to get a 14. So that does not work. So 14 is 84 is gone as well. Now similarly, if I put a 78 here, if I divide that by 6, I will get answer 13. Now, of course, I can get 13 here and here, but there is no number C possible, which 13 is not a multiple of 6. So I cannot get a 13 here. It's not possible. So 78 is off the table as well. 72. If I have a 72 divided by 6, it will be 1 and 2. Now this is a number that can work. Now if I had to, these are the after calculations one. If I have to get a 12 from this column, that means I should start with a 2. Only then I can have a 12 here. And now looking at these, I already have a 74 here. That means to make a total of 98, I have only 14 left. Let's see, if taking away 6 will also give 12, that means I should be starting with 18. That will give me 12. And adding 6 should give me 12. That means I should start with, sorry, this is 24. 74. And if I have to make 98, that's a 24. So I should start coming back. If I have a 6 here, that can add 6 more, and that will be 12. So I do get the same answers here if the numbers were 6, 18, 2, and 72. Now the only thing left for us is to add them and check if they give us the same number. 72 plus 2 is 74, 74, and 6 is 80, 80 plus 18 is 98, and we found out our answer. These are the numbers which will work for us. Now reading the question again, what is the sum of the largest 2 of my original 4 numbers? So the largest numbers are 72 and 18. So the addition is 90. So this is our answer, 90. We are on to question number 25. This is the last question of this section. When I ride my bike at 20 kilometers per hour, each wheel turns at 2 revolutions per second. When I ride 1 kilometer, how many revolutions does each wheel make? All right, so this is a speed question. Let's write it. So the speed of my bike is 20 kilometers per hour. That means if I ride my bike for 1 hour, it will travel 20 kilometers. Now, because it's in minutes and we will finally have to go for seconds. So let's see. So 60 minutes, we can travel 20 kilometers at that speed. Now, because it says that when I ride 1 kilometer, so that means for 1 kilometer, how much time would it take? So for 1 kilometer, 20 kilometers takes 60 minutes. So 1 kilometers will take 60 divided by 20. So that means 3 minutes. So 1 kilometer will take 3 minutes. Now, it is also given that each wheel is turning at the speed of 2 revolutions per second. And if we want to find out that in 1 kilometer, how many times the wheel is turning, we need to think about how many seconds are there. So we can figure out that in 1 kilometer, to run 1 kilometer, we need 3 minutes. So 1 kilometer will be done in 3 minutes, which means 3 times 60 equals to 180 seconds. So 180 seconds we can travel 1 kilometer, and each second, each wheel turns 2 times, 2 revolutions. So in 180 seconds, it will be 180 times 2. So it will be 360 revolutions. All right, and we have an answer here. In this puzzle, the triangle, the square, and the circle represents different non-zero digits. None of them are zero. Here we can see these are the 3 shapes that are used to denote 3 different digits and non-zero digits. What is the 3-digit number represented by the triangle, square, and the circle? Now, let's look at this equation closer. Let's have a closer look. All right, we are multiplying by 3. Now, if we actually look at the times table of 3, how many options are there? Now, what we can notice is whatever digit will appear here, in the answer, the units place must be the same digit because it's the same circle on both places. So if I actually, let's take an example. If I have a 1 here, but 3 times 1 is 3, but this and this represents circles. They should have been the same. So we cannot have 1 here. Similarly, let's try different. Can I have 2 here? 3 times 2 is 6, so 2 will not work. 3 times 3 is 9. That cannot work. Those have to be the same digits. 3 times 4 becomes 12, so it will be 2 here, which is not the same as 4. This will not work. 5, 3 times 5 is 15. Now have a look. So actually the digit here will be the same as Eunice's digit here. So we have found our first the circle must represent 5. And we can actually keep looking at different options: 6, 7, 8, 9. We cannot have 0. You can try different options here. There is no other digit which complies with this condition that if you multiply it by 3, the units place of the answer will be the same digit. So this has to be 5. We worked out one of those, and this will be 5 as well. Now 3 times 5 is 15, so that has a 1 exchange. Now again, what number should appear here? So 3 times something and add a 1 should end up with a 5 in the units place. If we have a 1 here, 3 times 1 plus 1 is 2, so 1 will not work. Can I have 2 there? 3 times 2 is 6 plus 1 is 7. That's not a 5. That will not work. 3 times 3 is 9 plus 1 is 10. That will be a 0. That does not work. 4, 3 times 4 is 12, plus 1 is 13. That does not work. 5, 3 times 5 is 15, plus 1 is 16. That does not work. 3 times 6 is 18, plus 1 is 19. That does not give a 5, so 6 does not work. 7, 3 times 7 is 21, plus 1, 22. That does not work. 3 times 8 is 24. Add a 1, and that becomes 25 with a 5 in the units place. And we found our answer. So there was an exchange of 1 here, and we just found out that 8 should be the digit here. So 3 times 8 is 24, plus 1 is 25. 5 goes here, and 2 goes exchange on the hundreds column. Now it's again, we found our square is 8, so the answer here has to be 8. Now it's easy peasy. What digit should appear here? So that 3 times something plus 2 is 8. Of course, that does not require a lot of calculation. It should be 2. 3 times 2 is 6, plus 2 is 8, and that gives our answer. So the question asked, what is the 3-digit number? Triangles, square, and circle. That is 2, 8, 5. That's the answer. All right, question number 27. Lee attempted to multiply a single-digit number by 36, but he accidentally multiplied by 63 instead. His answer was 189 larger than the correct answer. What was the correct answer to the multiplication? Now we know he had to start with a single-digit number. All right, so let's assume our number is A. So he was attempting to multiply by 36, but he accidentally multiplied by 63 instead. And we know that the answer that he got was actually 189 larger. So whatever the answer here he got, this was 189 more than this, whatever answer was supposed to be. So we know that this answer, 63A, whatever the answer here, if we take away the calculation from before, this calculation, that must lead to 189, because this was the difference between the two answers. 63 minus 36A is 27A equals to 189, and now we can divide both sides by 27. Now you can use the calculator for this bit, so which implies the number A, our original single digit number A, was 189 by 27. You can use a calculator. Let me show you. 189 divided by 27 is 7. So our answer is 7. This was the single digit number that we should have started with. But remember, our answer, they are not asking this question. The question is, what was the correct answer to the multiplication? So they are still asking the answer that was supposed to be here. So they are still looking for 36 times 7. Again, you can use your calculator. 36 times 7, that is 252. This is the answer to this question, 252. All right, this is question number 27. Let's move on. Let's read the question here. Using 9 out of 10 possible digits, so we have digits 0 to 9, so there are 10 digits. Using just 9 of those digits, Safia writes 3 numbers, each between 100 and 999. She adds her three numbers together. What is the smallest possible sum? Now we are looking for possible lowest sum, so let's make the space. So we are looking for, this is the first 3-digit number, second 3. I'm just making the place value holders for the 3 numbers that she's going to make, and I'm going to write down all the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and I missed a 0. All right, so these are the 10 possible digits that we have at our disposal. Now, because we want these numbers to add up to the smallest possible sum, that means finally the numbers that we start with should be small as well. So in order to do that, let's start with the smallest 3 digits. So we can have 0, 1, and 2. So, oh, just a moment. We could have started with 0, 1, and 2, but our numbers, the smallest number is actually 100. So we cannot have a 0 here. We cannot have a 0 here, so we'll have to take the next possible 3 here. So the 0 is still available, because we could not have, if we put a 0 here, that becomes a 2-digit number, and our smallest number is 100. All right, let's move on. So again, we want the smallest addition, so we will take the next smallest digits available, which are 4, 5, and now the 0, and use it in the tens place. 4, 5, and a 0. And because these numbers are finally going to get added together, so it does not matter where do you place these digits, because in addition, when you're finally adding all these together, the actual placement does not matter. The only thing that matters is which place value they are at. And now we have these digits left. So 4 and 5 are gone, 0 is gone, so we have all these digits left. But again, because I'm looking for the smallest, we are looking for the smallest sum, so we will only pick 6, 7, and 8, and 9 can be left untouched. So let me use the green. 6, 7, and 8. So these are the numbers, the 3-digit numbers that we can have for having the lowest possible sum. And again, you can use the calculator to find out the answer, but let's do this manual. 8 plus 6 is 14, 14 plus 7 is 23, 6 and 5 is 11, 3, 4, 5, 6, 7. Sometimes just bringing out the calculator and typing it takes much more time than an actual working out. So the answer is 713 as well. Let's have a read. Yifan has a construction set consisting of red, blue, and yellow rods. All rods of the same color are the same length, but differently colored rods are different length. So all red rods are the same length, but they all might differ in length from blue or yellow rods. Similarly, all yellow rods will be the same length, but not the same as blue or red rods. All right, she wants to make a quadrilaterals using these rods. Remember, they are using the word quadrilaterals, so it can be all same, all different. It can be trapezium, parallelogram, rectangle, square, anything. It just requires 4 sides. So 4 of these rods will join together to make a quadrilateral. It does not depend on the length of them. Now, there are some clues that they have given. When she uses 2 red, 1 yellow, and when she uses 2 red, 1 blue, and 1 yellow rod, the perimeter of the quadrilateral is 36 centimeter. Let me write it down. So I will 2 red. I am using the letter R to represent the length of red rod. So 2 R, 1 blue, and 1 yellow rod together, they join to make 36 centimeters. The perimeter becomes 36. Let's go on to the next clue. I'm just making number sentences right now. When she uses 2 blue, 1 red, and 1 yellow, the perimeter is 35 centimeter. Let me go back. So 2 blue, 1 red, and 1 yellow. When we use all these, the perimeter is 35. I'm not using units right now. You're just making number sentences. When she uses 2 yellow, 1 blue, and 1 red rod, the perimeter is 33. All right, let's write that down too. So 2 yellow, 1 blue, and 1 red, and the perimeter becomes 33. So these are 3 equations in 3 variables that we need to work out. Now, it might seem actually very difficult, but if you think about it, if I just add all of them together, remember thinking about all those rods that make these 3 quadrilaterals and putting them all together, that you're adding the whole of this plus the next perimeter, then the next perimeter. So putting all of these sticks together, and let's see what do they count to. So I can see there 2R plus 1R plus 1R. So let me use the red color here. So that will become 4 red rods. 2R from here, one from here, one from here. Similarly, let me say blue. So 1 blue, and 2 blues. So it will be 4 blues. And yellow might not be visible, but I still would take yellow. So there are 1 yellow here, 1 yellow here, and 2 yellows here. So if we add all the rods together, that will become 4 yellow, and these together, 36 plus 35 plus 33 is 104. Calculators are allowed in middle primary, so you can use a calculator, or just 30 is 90, and you can easily do 5 plus 6 plus 3, and that is 14. So the total is 104. Now from here we can see we can divide the whole left hand side by 4 and the right hand side by 4. Let me move it up. So this becomes red plus blue plus yellow is, this 2 is 4, 6, 26. All right, this is the equation that we have been looking for, and this is our savior equation. All right, let's have a look how this equation can help us get the answer. Now, if you compare this equation, so if we had 1 red, 1 blue, and 1 yellow, this will amount to 26. But look at equation number 1. It had 1 yellow, 1 blue, but instead of 1 red, it has 2 reds. So if we had 1 red, it's 26. Just adding another red here adds 10 more to the equation. Here is 26, here becomes 36. So just adding 1 more red, it makes it 36. So of course we can work it out. The red should be 10 centimeters, that means. Here is 26, adding 1 more red, big is 2R, and the equation changes to 36. Similarly, comparing this equation to the next equation, we have red, blue, and yellow is 26. In the second equation, we just add a blue more, and the answer changes from 26 to 35. That means our blue must be 9 to change it from 26 to 35. Similarly, if we compare again this equation to our third equation here, we just added another yellow here to this equation, and this changed from 26 to 33. We already had a red, blue, yellow. Red, blue, yellow. We added another yellow, and it changed to 33. That means yellow must be 7. So we found, actually, you can see we found the measurement for all our different colored rods. So red was 10 centimeter, blue was 9 centimeter, and yellow is 7 centimeters. Now let's read the question. What number do you get when you multiply the lengths of 1 rod, 1 red rod, 1 blue rod, and 1 yellow rod? So this is easy. You just have to multiply 10, that's red, length of blue, and length of yellow. So 9 times 6 is 63, and then multiplied by 10 is 630. So this is our answer, 630. This is an excellent question. 10. All right, go on to the next question. Oh, this is the most interesting question, and the question which requires tremendous amount of visualization and pattern making to find out the answer. And just for you to know, because I have solved the middle primary level, a similar question appeared in middle primary level this year, but in that question they were asking only for pattern 5. So that was an easier level of the same construction. So let's read this. This, of course, is upper primary, so they have increased the level of difficulty for this question. Janice is making patterns using square tiles. We can see it here. Each pattern is made by copying the previous pattern. So whatever was the previous pattern, they copy and they build on that. Then adding to it a tile to every grid square that shares an edge with the copied pattern. So they start with pattern 1, only with 1, then they build up this tile, and we can see that they build up in alternate colors. So they started with a dark tile. In the second pattern, they added the light colored tiles, and then in pattern 3, they kept the previous all pattern and they added the dark tiles around. And then in pattern 4, they kept the whole pattern 3, and then now alternatively they added the light colored tiles around. I marked too much, let me take that away. All right, so the question is, his last pattern is the largest one that can be made with fewer than 1000 tiles. So if we continue going in this pattern of adding tiles on the edges, alternating between the colors, what would be the largest one that can still have fewer than 1000? So we are still looking for the 3-digit numbers tiles. Now, in order to find such a big one, we will not be able to physically keep on building the pattern. We will need to find a formula, a sequence, so that we can build on that. Now, to do that, you have to spend some time closely looking at these diagrams and seeing what is happening. I did spend the time, and what I found was, let me show that to you. So the first one is 1, of course, 1, but I will not start with that because it does not give me any pattern. What sequence should I make? The next one, there is a 1 here, and there are 4 more here. Now, if I continue to write that, that's 1. That's first pattern is 1. The next one is 1 plus 4. Now, the third one starts getting a little bit more complex. But if I look closely at it, look at the dark light colored tiles. There are 4 light colored tiles, and if I look at the dark colored tiles now, let's choose a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 3 rows of 3s, so there are 9. And now at this stage, let me use the same color. Let me find one more. And now, actually coming here, we realize even for the darker tiles, now you can see the pattern. There are 3 groups of 3s. There are 3 groups of 3s rather than just counting on, because as the pattern keeps on getting higher, it would not be physically possible to keep adding them on. So now let's look at, and the darker tiles, you can see there are 1 group of 4, second group of 4, third group of 4, and fourth group of 4. So not a comma here, that's a plus 4 times 4, and I must put the bracket so that we know the order. So actually we can modify our sequence that we have written. So this is 3 square plus 4 square. I can easily see these are 3 times 3 of the darker tiles, 4 times 4, 16 of the lighter tiles. If we look at the pattern before, so these are 2 square, 2 square, 2 times 2 of the lighter one, and 3 times 3 of the darker tile. So instead of writing 4 plus 9, because I'm trying to build a pattern so that we can continue on it, that's 2 square plus 3 square. Similarly, looking at this one, this is just 1 tile, so instead of writing it 1, we can write it 1 square, and the lighter tiles are 2 times 2. So that's 1 square plus 2 square. We are not altering the numbers still remain the same, but now we can see a pattern which can extend on it. And similarly, 1 was 1, but now building on this pattern, we can say that is 0 square plus 1 square. And now we can easily see this is pattern number 1, this is pattern number 2, pattern number 3, pattern number 4. And the moment you realize this, you are very near to the final solution, because now you know, does not matter how far you go away, if you are on pattern N, the formula would be the same. Pattern 2 had 2 square and the one before. Pattern 3 had 3 square and the number of the square of the number before. So if you're on the nth one, it will have n square plus whatever number was before square of that number. You don't need to worry if you don't understand this formula, but it doesn't matter. So we are looking for an answer so that a number is still a 3-digit number. So now let's try to work it out. So you can, because we are allowed a calculator, you can actually work on that to find out. Let's take a random one. Let's do 20. So if it was pattern number 21, so it will be 20 square plus 21 square. And let me write it. So this is pattern number 21, and pattern number 22 would be 21 square plus 22 square. And similarly, pattern 23 would be 22 square plus 23 square. And now you can put these values in the calculator and find out the answers. Now, so 20 square is 400 plus 441, so that's 841. So I can see that's a 3-digit number, but let's try out if this is still a 3-digit number. So 21 square is 441. 22 square, you can work it out or just use a calculator. That's 484. So that means it is 5, 12, 925. And oh, that's quite close to being 1000, but just to make sure, let's go ahead. 484 and 23 square is 529, and 529 and 484. Oh, we can see that this has crossed the value, and now this has become a 4-digit number. So we are definitely don't want a 4-digit number. So we have to stay put at this step where our answer was the last pattern with still a 3-digit number, less than 10,000. So, and this was pattern number 22nd. So let's read the question again. How many tiles are in the last pattern? Okay, so they're not asking how many patterns, but they need 925. So that is our answer, 925. And this was the last question of our upper primary AMC. I hope you all did really well, and for those who are taking part in 2024 AMC, all the best to you. Do keep watching this channel, like and subscribe. I've also solved papers from the previous years. If there is a certain paper or certain question that you're looking answer to, just drop it in the comments and I will try to provide you the solution.